This is a tutorial for the study guide for algebra number 7, or quiz 7. So let's take a look at our first problem. It says that 28 girls went camping. There were two main activities, volleyball and swimming. It says that 14 girls went swimming and 5 participated in both activities. 4 girls did neither activity. Okay, so let's find out how many girls participated. So out of those 28, we have to subtract 4, so only 24 participated in an activity. And so we just don't know which ones did what, and so in an activity. So let's go ahead and find out. Let's start by drawing our Venn diagram here. And we've got one of the circles will represent volleyball, and then the other circle will end up representing swimming. And so what we do know right away in our Venn diagram is this part right here. It says 5 participated in both. And so I can put the 5 right here. So out of those 24, 5 end up participating in both activities. And right here's another bit of information. 14 girls went swimming. So 14 wouldn't go in this spot right here because the 5 is included with that 14. So what I need to do is find out how many girls went swimming alone. So instead of a 4 there, that should be a 5. So I'm going to take 5 away. I'm going to take these 5 away that went swimming and did volleyball and find out how many just went swimming. So this is swimming only. And so that would be 9. So 9 of them went swimming only. Now we got one more bit to do. It's just how many people played volleyball. And it says, and that's really what they want us to find. And so what we're going to do from here is we're going to end up starting with the amount of people who ended up going swimming only, and we're going to take it away from those that did just one activity. So that's what I need to do next, is find out how many did just one activity. So we're going to go back to that 24 who participated in an activity, or more than one, and let's go ahead and subtract out the 5 who did both. So that means that 19 people did only one activity. So what we can do now is, since there were 9 people who only did swimming, and then plus another number of that did volleyball, and that would sum to the 19. So now I can just take the 19 and subtract those 9 people who went swimming only, and that leaves me with 11. So 11 did volleyball only. And so that's the answer for this problem. So there it is, our Venn diagram. The Venn diagram kind of shows the answer for how many students or how many girls did volleyball. So the next one says, draw and label the axes to represent the situation. The hours of daylight for each day over the course of a year. So let's start with a graph. We've got our y-axis and our x-axis. And so our x-axis is going to represent the year, course of a year. And I'm going to add in maybe like starting in December, and then maybe halfway through here is June, and then back to the end would be November, and then December again. So this is my x-axis, that represents years, and then my y-axis I'm going to represent with hours of daylight. Hours of daylight. So I'm going to say that in December we don't have very much daylight. So this is maybe a few, maybe like maybe 8 hours or so, depending on where you live. If you lived in Alaska, it might be down here near 0, but up here maybe a little bit more. And then throughout the course of the year, through December, maybe we're decreasing a little bit. If this is the 1st of December, it might decrease a little bit here, but then we're going to start to increase once we get in January, and then we're going to continue to increase. It's going to increase and increase and increase, but then once we get to June, it's going to end up decreasing again. And so it's going to pretty much stop up there and then come back down the same way it went back up. And it's going to decrease and decrease and decrease. And so until we get down to November again, and then it's going to continue to decrease in through December. And so that might be a representation of it. So these can vary a little bit, but it needs to make sense. And so for Placerville, this would be a pretty good approximation of what happens. Might have gone down a little bit too much, but mainly about December 21st or so, then it starts heading back up, so we continue to gain daylight until we reach somewhere in June where it starts to decrease again. So let's take a look at our next problem, and that one says that the store marks up merchandise it sells by 55%. Wholesale, which is like before they end up selling it, costs the store $35 to purchase an item, and then what should the retail, what the store actually sells it, what should that sell price be, or what should they set it at? So they want to know what the final price is. So we're going to take that $35 item, and we're going to multiply it by a percent. We're going to multiply it by 100%, which will not change the value, and then we're going to add on that 55%. And so together, that would make 155%. And so what we have to do from there, though, whenever I'm dealing with percents and I want to find out how much something is, or a percent of something, I need to change that to a decimal. So it's going to be 1.55, and then I'm going to multiply that by 35, and that's going to give me $54.25. So let me fix that 50 real quick. So from there, we'll take a look at our next problem, and that one's also going to end up being a percentage problem. So it says that in a savings account, so at least it has percentage in there, it says that in a savings account, the simple interest rate is 6% per year. Last year, the account earned and then this much interest. What was the balance in the account at the end of the year? Alright, so we need to find out how much did they put into the account initially. So we're going to use this formula, I equals PRT. Now, I want to find the principal, so I'm going to divide by the rate and the time. That's going to give me how much we started with. So I'll start with my $10.86 of interest, multiply or divide that by the rate, which is 0.06, and then my time was 1 year. And so that's going to give me my principal. So I go ahead and do some work there, and that gives me $181. That's what the principal is. But that's not what they want. They want the balance. Balance means together, how much did they have at the end of the year? So they're going to add the interest plus the principal is going to equal the balance. And so that's what I need to do next. I need to take the $10.86, and I need to add on that $181, and that's going to give me $191.86. So the next one says Al bought a house in 2001 for $130,000. He sold it in 2015 for $350,000. Find the percent of increase. So percent of increase is a percent of change, and they're pretty much done the same way, whether it be an increase or decrease. Basically subtract the two numbers, and it doesn't matter whether it's a positive or a negative number. So I'm just taking the absolute value of that answer, just want the difference, and I'm dividing always by the original number. So whichever one comes first. So this has to be the original number. And then I'm going to take that answer and then I multiply it by 100, and that's going to give me the percent change. So I go ahead and do that subtraction, and I ended up with $220,000. And I'm dividing that by $130,000. And then I'll times it by 100. And so when I do that, I get somewhere, it's a decimal, after I multiply by 100, I get somewhere around 169%. So the next one's also a percent change type problem, but they call it percent error, but it's pretty much done the same way. We're going to, it says that the decorator estimates that the rectangular rug is 5 by 8 feet. The rug is actually 4 by 8, and so I want to know what is the percent error of the area. Well, area means I need to find the area. So 5 times 8 gives me 40. So this was the estimate for the area, and 4 times by 8 is 32, and this is the actual. So it's done the same way. We subtract the two numbers. Doesn't matter what the sign is there. That's why we take the absolute value. But we always divide by the actual. Divide by the actual, not the estimate. So the actual is 32. and then we multiply that by 100. So when I do that, I get 8 over 32 times by 100. Reduce the fraction there, I get 1/4, and a quarter is 25%. So if I did that math, that's what I'd get. Well, let's take a look at the next problem, and it says solve for y. So what I'm going to do first is move the x term over. So you subtract the 5x from the 6. But since you can't take 5x from 6, you leave those apart. So I'm going to write it as negative 5x plus 6. So I just left them as separate terms. And then the next step is to divide by 2. But when you do it, you divide every number by 2. And so when I write the answer, I'm going to write it as negative 5 halves x plus 3. And that's it. So this next one asks us to solve for L. So first step is to get L, or the term with L, by itself. So since I've got an addition sign there, I need to move that over. So I'm going to do an opposite operation. I'm going to subtract that pi r squared from both sides. Subtract pi r squared. So now I have s minus pi r squared equals pi r L. So now I'm going to go ahead and get rid of that pi r by dividing by pi r. But I divide each of the terms by pi r, since I've got two terms in there because they're separated by that subtraction sign. And that leaves me with s over pi r minus, now here the pi's are going to cancel out, and one of the r's is going to cancel out on top. So it leaves me with just one r left. And so that's how I'm getting L equals s over pi r times, or minus, r. So the next one says two-part. Solve for c first. So I'm going to subtract the 32. And when I do that, I have now f minus 32 equals 9/5 c. So the next step is to get rid of this fraction. And you get rid of fractions by multiplying by reciprocals when those fractions are being multiplied by a variable. And so I do that on both sides. So I multiply this side also by it. Now I have to put parentheses around this subtraction problem because I've got to do that first before I multiply by the 5/9. So my answer is 5/9 times by the difference of the degrees Fahrenheit minus 32 equals degrees Celsius. So that's part of the answer right there. The next part is to figure out which is the warmer temperature, the sun or lightning. So I'm going to take the sun's temperature and put it in place of F. And so 5/9 times by, and then 11,000 minus 32 equals C. So I go ahead and do that subtraction. I end up with 10,968. And multiplying that by 5/9, I get something around 6,093.3 repeated equals the degrees Celsius. So obviously I see lightning is much, much hotter. So 30,000 is greater than 6,093.3 repeated. So I would say lightning is, or has, the greater temperature. So those are the problems that you'll see on this week's test. Good luck.